If this is your first time here in this channel, it's all about educative stuffs. So don't forget to subscribe, ring that bell notification to get instant updates, smash that like button. Hello guys, Code 4 is back with another video on Unit 4 of IGCSE Computer Science, Operating System and Computer Architecture. The main topics we'll be covering today in this video are shown: operating system, interrupts and buffers, von Neumann architecture, also known as computer architecture, and finally, fetch execute cycle. Firstly, operating systems. Operating system is an essential software running in the background. Most of you would have known it as OS in short. Examples include Windows, Apple, Android, and Linux. The functions carried out by operating systems are multitasking, multiprogramming, error handling, batch processing, human computer interface, input output control, security, and memory and processor management. What happens when you switch on a computer? Initially, programs are loaded into the memory from the ROM, which stores memory permanently even when the computer is turned off. These programs run to check if there is any error in the hardware, software, or BIOS, basic input output system. If no errors are detected, OS is loaded into the memory. Moving on to the next subtopic, we have interrupts and buffers. Interrupt is a signal sent from a hardware or a software to the processor. Once the processor has received the interrupt signal, the processor will temporarily stop what it is doing and service the interrupt. Interrupt allows the computer to carry out multiple tasks at the same time. Examples are occurrence of errors such as paper jam in a printer or user has pressed a key. Example Alt plus F4 simultaneously to end a process. Next up, we have buffers. Buffer act as an intermediate between the processor and the hardware. The processor fills the buffer with instructions and carries out its other tasks. The buffer empties the instructions to the hardware. Why this is done? That is because processors are much faster than the hardware. If it wasn't for buffers, the processor would have spent majority of its time waiting idle to get responses from the hardware. How are interrupts and buffers used? In this example, we'll be seeing it with the printer and printer buffer. First, any data sent to printer? No, the processor carries on with its tasks. Yes, print data sent to buffer from the computer memory. Then, the contents of the buffers are emptied to the printer and printing takes place. All the data sent to printer? No, the processor can carry out its other tasks while the buffer is being emptied. Yes, when all the data has been printed, the buffer becomes empty. So, interrupt is sent to the processor for more data. The current task is suspended while the interrupt is being serviced. Next up, we have the von Neumann architecture. This is the basic von Neumann architecture. This shows the idea of how processor and memory unit are linked together by connections known as buses. This is a simple representation of von Neumann architecture. The red one is the address bus, the green one is the data bus, and the blue one is the control bus. Let's get to know about buses even better. Buses, address bus, carry signals related to address between processor and memory. This is unidirectional. Data bus sends data between processor and memory unit. This is bidirectional. Control bus carries signals related to control and coordination of all activities within the computer. This is both unidirectional and bidirectional. This is the detailed image of von Neumann architecture. It brings our attention to another new concept in this computer model: the idea of addresses and registers. Addresses indicate where the data is stored, and the registers are needed so that the data can be manipulated within the computer. An address is the location. An address is the location where the data can be found in the computer memory. Each address in the memory is unique. The address aren't actually shown in this figure, but they are contained in the memory unit. You will notice a number of items shown in the diagram known as registers like MAR, MDR, ALU, PC. and CAR. Essentially, a register is simply a high speed storage area within the computer. All data must be represented in the register before it can be processed. For example, if two numbers are being added, both the numbers must be stored in the registers and the result of the addition must also be stored in a register. We have come to the final subtopic of this video, fetch execute cycle. Before knowing the fetch execute cycle, we should know about the registers. ALU, arithmetic and logical unit, performs arithmetic and logical functions. CIR, current instruction register, holds the current instruction being processed. PC, program counter, which contains the address of the next instruction to be fetched. MAR, memory address register. MDR, memory data register. So now into the fetch execute cycle. First, the program counter PC contains the address of the memory location of the next instruction which has to be fetched. Then, the address is then copied from the PC to the memory address register MAR. This is done using address bus. The contents instructions in the memory location address contained in the MAR are then copied temporarily to the MDR memory data register. Then the contents instructions of the memory data register are then copied and placed into the CIR current instruction register. The value of PC is incremented by 1 and points to the next instruction to be fetched. The instruction is finally recorded and executed by sending out signals via the control bus to various components of the computer system, and this follows a loop. Then, finally, key points to remember. Processor. Processor contains ALU, arithmetic and logical unit, which allows arithmetic and logical operations to be carried out. ALU is used to store the results of the calculation. Control unit makes use of CIR and PC. Sends control signals that manage the transfer of data and instructions within the CPU. It decodes an instruction using the instruction set. Registers. Registers are high speed storage area. Thank you guys.